So just as a reminder, whenever you're turning these in, I still want to see you working these by hand. So if you have to draw them out and work them out, that's fine. But I want to see that you know how to do them by hand, because who cares if you know how to work code that I show you how to type and you just type it. The whole point is that you're understanding the algorithm and what's going on. So anyway, like I said, make sure that whenever we worked this out that you actually physically worked it out. So you've got the MATLAB script that should do that. So let's look at problems 4, 5, 6, and 7. So this one I want you to do by hand as well. So first of all, I'm going to have you do it starting at A, and then I want you to find it starting at H. So you're going to have to do this twice. So I think I made it a little bit bigger down here to kind of play. Yeah, here we are. So if I'm starting at A, I'm going to do the thing where I go and label everything as infinity, 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 and infinity. But since I'm starting at A, I can go ahead and mark this as a 0. Okay, so just to kind of get you started, 0 plus 2 is 2. I'm going to make it a little bit messier, but you can make it pretty. Make sure. So basically what I'm saying is I want to see in your notes that you've actually scribbled this out. I don't want you just to have the thing and the answer. I want to see that you went through the process. So 0 plus 4 is less than infinity. All right, and those are the only places I can go from there. So this is officially visited. Okay, now the next non-visited one would be the 2. So I'll start at 2. So I've got 2 plus 3 is 5. That doesn't do me any good. 2 plus 9 is 11, which is definitely better than infinity. 2 plus 2 is 4, which is definitely better than infinity. And 2 plus 4 is 4, which is again, 2 plus 4 is 6, which is again definitely better than infinity. All right, I've gone everywhere I can from there, and I'm done. So I'm going to mark that finished. So that number is 2, that number is 0. Now I have the choice. I can either, so I've got 4, 6, 11, 4, infinity, and infinity. Obviously, I'm trying to choose between the 4 and the 4. It doesn't really matter which one you pick. You're going to end up with the same answer anyway. So just know that going forward. I'll do one more round for you. I'll start with this one. No, that one's too boring because it only goes one place. So I'll start with this one. So let's say I've got 4 plus 3 is 7. 7 is definitely less than infinity. 4 plus 1 is 5. 5 is definitely less than 11. And those are the only unvisited nodes I can go to. So that means I am now officially done here, and I've got an answer to go there. Okay, so just to show you what this is going to look like in MATLAB, you've got this lovely map. And basically, again, I think it's hard to get all this correct. So that's another reason why it's nice to do it by hand so that you know that your map is good. But remember, down this diagonal, you're going to have zeros, and down these diagonals, you should see it be symmetric. So just so you know, here's the answer. Getting the answer is not the hard part. It's figuring out how to do it and how to do it by hand. Now, whenever you're doing this for the next problem where it's asking you to do it from H, I mean, just doing it on paper, obviously, shouldn't be a huge deal doing it from H, but if you are doing this in the calculator or the computer, it's B. 1, 2, 3, 4, 5, 6, 7, 8. So instead of going map and 1, come back here, you would do map and 8. All right. Let's see, what else do we got? This one here is a little bit harder because look at these are not bidirectional. So the cost to go from B to H is 12, but the cost to go from H to B is actually infinity. Okay, so that means that you're still in your maps. You're going to have zeros down the diagonals, but it's not going to be symmetric from upper diagonal to lower diagonal, or upper right triangular to lower left triangular. And that's because, like this says, it takes 2 to get from C to B, but you can't go from B to C at all. There's no way to get there. Let me give you a couple of those numbers just to get started. Like if you were looking at what the output would be in MATLAB, the first couple of numbers that you're going to get are going to be 0, 14, 12, 5, and 9. So again, the good news is that either you do it by hand and you confirm your answers are right by doing it with the computer, or you do it on the computer, and then make sure that you're getting the same thing by hand. You know what I mean? The opposite, basically. The last question here is kind of cool, and I want you to take a little bit of time and think about it. The question says, oh yeah, sorry. Before I do that, no. We'll go ahead and do this for a second. It says, will Dijkstra's algorithm work for paths with negative edges? So basically, my idea would be if you had like, I don't know, something like A, B, C, and D. Like, let's pretend this cost 2, but this cost -3, and this cost 4, and this cost 2 or 5 or whatever, and this costs 6. No, I think I'm going to do this as a 7. No, that's the opposite of what I know to do. 2, let's call this one a 7. Do Dijkstra's algorithm and see what happens. And then, so first of all, I'm just going to tell you it's not going to work, but I want you to figure out why it doesn't work. And also, it doesn't work to just say, well, I'm just going to up the number of all of these by 7. I'm just going to add 7. I want you to figure out why that doesn't work either. So this is kind of like a counterexample, but I want you to show me why, for example, well, first of all, why this doesn't work. And then if you can come up with a good counterexample of why just adding 7 to everything doesn't help either. Because again, remember the idea is to visit every single node, but to only visit, we don't want to, I don't know how to say it, but Dijkstra's algorithm does not work for negative edges. So I just want you to figure out why and kind of play around with it. So hopefully that's enough to kind of get you started. And definitely let me know if you have any other questions putting all this together. Oh, I remembered what I wanted to say. At the end of this, you should have your MATLAB code where you have your Dijkstra, and then your practice, and then you would have like the problem 2, problem 5, problem 7, and then the last problem. So have whenever you turn in your files, make sure you turn in all of your MATLAB files. But I still can't spell. I also want to see your handwritten solutions. So make sure that you give me your handwritten solutions as well. And it's totally okay, by the way, to go online and ask Google why Dijkstra doesn't work. I mean, that's part of, on negatives, that's, again, part of the fun. And if you really want, again, you can kind of look up the Bellman-Ford. I did that again. The Bellman-Ford algorithm, because that one does work for negative edges, but it's a lot harder to solve. So yeah, I just wanted to remind you that I don't just want the MATLAB. I want the MATLAB plus the handwritten solutions, showing your work, of course.